Have you ever looked up at the stars and felt that humbling awe, that sense of staring into an endless expanse of unknowns? For centuries, humanity has tried to map out the cosmos, to guess how it all began and how it might end. But now, for the first time in our history, a group of scientists decided to give that enormous question, our entire universe from beginning to end, to an advanced AI model. They fed it data from cosmic background radiation, star formation patterns, black hole physics, and every scrap of astrophysical observation we've ever recorded. Their mission was simple yet mind-blowing. Show us how everything started, where it's going, and when it might all cease to exist. The results they got were unnerving, to say the least. At first, they expected more or less a cosmic play-by-play, a timeline from the Big Bang onward, peppered with the usual phenomena: expansion, galaxy clustering, star formation, black holes swirling, supernovas bursting. We've had smaller attempts at universe simulations before, massive supercomputer projects that tried to replicate galaxy formation or map out dark matter distributions. But this time, the scientists added something different. An AI sophisticated enough to reinterpret missing pieces, to cross-reference contradictory data, and to propose entirely new cosmic events we'd never predicted. They wanted the AI's creativity, if you can call it that, to fill in the blanks. The early stages of the simulation looked normal enough. The Big Bang erupted in a surge of searing energy, birthing fundamental particles. A swirl of plasma eventually cooled and congealed into atoms. Gravity took hold, forging the earliest stars. The cosmic background radiation pattern we know so well appeared precisely on schedule. So far, so textbook. But then, the simulation began to delve deeper into phenomena we only partially understand. In particular, it examined black holes, those gravitational monsters that devour stars and warp spacetime. The AI discovered subtle patterns in how black holes devour matter, generating gravitational ripples and high-energy flares. Some of these patterns matched existing theories, but there were new twists too. The AI predicted that in certain rare conditions, black holes can engage in merger chains, a sequence of black holes merging at an accelerated rate, generating monstrous, supermassive black holes far earlier than we'd expect. If that happened in a crowded region of the early universe, the entire cosmic structure might reorganize around these gravitational behemoths, warping star formation across billions of light years. We never encountered that scenario in prior studies, because we typically assume black hole mergers happen sporadically. The AI said it might happen in waves. But cosmic black holes were just the appetizer. The real shock came when the simulation advanced into the present day, and beyond. If you've followed astrophysics, you know the Big Crunch, Big Freeze, and Big Rip are the three main contenders for how the universe might end. The Big Crunch imagines everything reversing, collapsing into a singularity again. The Big Freeze posits that expansion continues forever, stars burn out, and we drift into eternal darkness. Meanwhile, the Big Rip suggests that expansion accelerates so violently, even atoms get torn apart. The AI recognized those classical endings, but then proposed a new spin. In analyzing the distribution and nature of dark energy, which, ironically, we barely understand, it suggested a scenario where space-time might phase shift, as if the dark energy changed in character over eons. The AI's modeling displayed a timeline where around 200 billion years from now, cosmic expansion speeds up extremely, but not quite to the point of a full-blown Big Rip. Instead, galaxies recede from one another at near ludicrous speeds, yet remain stable within themselves, forming isolated pockets. Then, in an astonishing twist, after some threshold the AI calls a cosmic pivot, the expansion suddenly abates, as though the dark energy's influence flips sign, and the universe's expansion halts. Regions that were flung out stop receding. over an even longer timeline, they reconverge. If that were all, it might be an interesting new theory. But what made the scientists truly uneasy was how the AI found patterns that might lead to cosmic cataclysms, well before that distant future. The AI identified dark energy fluctuations, like storms or quakes in the fabric of spacetime, capable of spontaneously ripping star systems out of their normal orbits. According to the simulation, these fluctuations are extremely rare, but not impossible. They might be the cosmic equivalent of an earthquake in a stable region of tectonic plates. One event of that nature, happening within a galaxy cluster, could sabotage entire civilizations. The AI added a footnote, metaphorically speaking, indicating that even a small chance of such a fluctuation per eon, multiplied across billions of galaxies, suggests it might have already happened, out there in the darkness. We just haven't noticed because the aftermath is invisible. Then came the part that shook everyone. A few lines of the AI's output hinted that based on gravitational wave data, some ephemeral energy ripples might be nudging our local cosmic neighborhood in ways we can't fully detect. If that's accurate, we might be careening toward a large-scale cosmic shift in a fraction of the time we assumed, possibly within a few 100 million years. That might sound like forever from a human standpoint, but it's terrifyingly soon in cosmic terms. Meanwhile, the AI also indicated a small, but non-zero chance that such a phenomenon could accelerate and occur within the next million years, or even a sudden alignment of unknown factors that might cause a cosmic jolt in mere tens of thousands of years. Of course, these are all model predictions. The AI's advanced reasoning might be flawed or overfitted to incomplete data. Some astrophysicists caution that an AI can produce mathematically plausible but physically absurd ideas. However, that's precisely why this is so alarming. The AI didn't just replicate known theories, it offered entirely new scenarios. Could it be glimpsing into cosmic truths we haven't discovered? Or is it spinning exotic tales from chaotic data? People are already asking, could AI-driven cosmic modeling become our new cosmic oracle, overshadowing traditional astrophysicists? The worry is that we might rely too heavily on machine logic, ignoring the fact that we can't interpret some leaps it takes. If it foresees an apocalypse, do we scramble to research cosmic defensive measures? Or do we treat it as curiosity and keep living our small, short-lived lives? Regardless, the reaction from the research community is a mix of wonder and dread. Some want to replicate the experiment, verifying the AI's methods step by step. Others fear it's a Pandora's box that might distract us from more pressing problems, like ensuring our civilization even lasts long enough to worry about universal fates. A smaller group embraces it wholeheartedly, viewing it as a clarion call to invest in interstellar exploration or cosmic refuges. Get off Earth while we can, colonize exoplanets, hedge our bets against these cosmic unknowns. In the end, maybe the biggest takeaway from this AI simulation is that we are at the infancy of truly understanding the universe. Our cosmic knowledge might be akin to a toddler's grasp of advanced mathematics, while these new AI models have the capacity to leap several conceptual steps ahead. That can be exhilarating, or it can be horrifying if it tells us the cosmic story ends in some unimaginable catastrophe. Whether you find this revelation thrilling or terrifying, one thing's clear. We are stepping into an era where advanced AI doesn't just manage data, it interprets the entire cosmos on a scale we can barely comprehend. If that leads to breakthroughs in how we plan cosmic missions or defend ourselves from potential black swan cosmic events, great. But if it merely reveals that our fate is sealed by universal laws we never suspected, well, we might have to brace ourselves for that knowledge. Because sometimes, the scariest answers come from questions we didn't realize we were even asking. If you found this exploration mind-blowing, do me a favor. Like this video, subscribe, and share it with a friend who loves pondering the mysteries of the universe. Because if AI is starting to see truths in cosmic data that we humans can't, we are in for a wild ride. And we'll need every informed mind we can get, whether it's to avert catastrophe or simply marvel at the grand design. The universe is bigger and stranger than we ever imagined, and AI just might be the lens that lets us glimpse its most hidden chapters.